All right, so we're looking at lesson 6, which is a continuation from lesson 5, essentially looking at stretches about the x and y axis. I want you to remember the idea of reflections. Reflections are the lesson we completed already. It's when y was replaced with minus y, and that was actually a reflection in the x-axis. And if the x gets replaced with a minus x, it's actually a reflection in the y-axis. So we want to remember those ideas as we go through today. Always note the review. They do a really good job setting up what we've already learned. I'm going to slide down to example B and C. And I'm going to try and talk through my thinking. I want to write the equation when the following things happen. So horizontal stretch by a factor of 4 about the x-axis. Remember, x's act oppositely. So that means the x is actually going to get replaced by the reciprocal of 1/4. And depending on how you treat the y's, it's either reciprocal or not. I'm going to try to treat it as if we were operating on the left-hand side. So it's also going to be a reciprocal, which makes this convenient. So a vertical stretch by a factor of 2 would be 1/2 y. And now I get to rewrite my equation and simplify it as much as I can. Now it's going to be a while before we deal with square roots, so my simplification might be a little confusing. I've tried to record all my steps. I've replaced my y with a half y. I've replaced my x with a quarter x. And then I've tried to simplify. So the blue statement is just plain plugging in. Then I moved the half over to the other side. I needed some brackets. The 2 distributed in. It has to still hit the square root sign yet, but it hit the 3 and made it a -6. You might remember that you can square roots numbers like a quarter by taking the square root of the top and the square root of the bottom, which gives me a 1/2. And that led to some nice simplification. Trying the same thing again with C. Again, just setting up, looking for what happens to x, what happens to y, looking for that to happen multiple times. A vertical stretch about the x-axis is doing what? It's actually working on y, not x. So that vertical stretch is going to manipulate my y. And I'm going to deal with the reciprocal idea. So I'm going to say that y is going to become 3y. And then the reflection in the y-axis, remember, changes y to negative y. The net effect of this is my y is going to get replaced with -3y, and then I have to try to resolve. Go ahead and try that out. So I replaced my y with -3y, and then performed some algebra, divided both terms on the left-hand side by -3. My 3 becomes a -1, and my 7 becomes a -7/3. So a little bit more practice with these doubles. Let's turn the page. Gonna try and have some fun with trying to predict what happens to the graph. Remember, you can always plot it, so that's always exciting. I'm going to do ACE. So the replacement of x with a half x is going to be a horizontal stretch of 2 about the x-axis. Pardon me, about the y-axis. Two things are happening in C. My y has been replaced with -y, and I've got a 2 hanging out there. So I've got a vertical stretch of 2 about the x-axis. And then I've got a reflection in the x-axis. So two things are happening there. And I've got some of the same things happening in E, except I have two stretches. I have a vertical stretch that's the same. So I've got a vertical stretch of 2 about the x-axis. And then I have a horizontal stretch. Remember, you need to take the reciprocal of x, a horizontal stretch of 3 about the y-axis. And now we're going to see if we can apply it to a graph. We'll try looking at the graphs, both A, B, and C. I didn't like the graph of A at first, but what's happening to it? It used to crest up to 6 at the Y value, but now it's just down at 3. So I'm looking at a vertical change because it got shorter. So a vertical stretch. And because my 6 went to 3, I know that that vertical stretch is a factor of a half. And nothing else seems to have changed. I get to write my equation as y equals 1/2 times 6 over x squared plus 3 plus 1, which you could simplify as 3 over x squared plus 1. Now the other two graphs seem a little bit complicated. I'm looking at the weirdest shape of my f at x graph, and what do you see? So I think I see that the graph has become taller somehow, and that is something I have to try and measure. So my graph used to be 1, 2, 3, 4, 5 boxes tall. It's now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes tall. So I'm going to suggest that my y has been stretched or replaced with 1/2 y. So y is equal to 1/2 y, but a little bit more is happening there. Y is equal to 1/2 y. I also have reflections. I don't have the solid part of the graph in any one location. What seems to have happened is that I've reflected in both axes, axi. The x has been replaced with minus x, and the y has been replaced with minus y. And I get to write a really cool form of the equation. My y is now 1/2 y, but it's negative. So 1/2 negative y is equal to f at minus x. See if you can follow how that worked out geometrically or by looking at the graph. The next graph is actually a graph of a polynomial, which is something that we'll study later on, like a whole unit on polynomials. But I thought it would be interesting to see what happened. The original graph had x-intercepts that are trackable, and they shifted out. They became larger. My x-intercepts shifted out. This one moved over here to the thick line. This one moved over here to the thick line, and this one moved all the way over there. Well, how do I figure out that horizontal stretch? So I've got a horizontal stretch, which is about the y-axis or relative to the y-axis. What happened to those points? Well, what I saw is I saw that -4 here went to -8. So my x was stretched by a factor of 2. Somehow that stretching took my x-intercepts and changed a 4 into a -8. And that would have been by multiplying by 2. Now we know that the representation in the formula is opposite. So I see the effect of timesing by 2, but the statement for my x is that the x got replaced with the reciprocal. The x actually got replaced with a half x. Try graphing this one. It's kind of fun to look at. Adjust your scale so you can see the window in the same way that it's presented. Every x gets to be half x. So it's 0.5x plus 4 as one factor. And the other factor is 0.5x minus 2. And the other factor is 0.5x minus 6. Now we have time to hit our lesson. I hope you've been able to watch this either at night or in class. Thank you very much.